Well, good afternoon, everybody. Welcome to our second session of the hydrogen unit for our Run on Less Messy Middle Bootcamp series. My name is Rachel, and I am the Industry Engagement Manager at NACFE and the moderator for our session today. If we can go to the next slide. So as we get started today, as always, I just want to thank the team over at ACT News. They are the group that provides all of the technical support to our bootcamp sessions, and they are the premier source for the latest clean tech news from the commercial transport industry. So if you are not subscribed, be sure that you subscribe today. If we can go to the next slide. As I mentioned, this is the second session for our hydrogen unit. And 2 weeks ago, we hosted our first session that was all about the production processes of hydrogen. That recording is on the NACFE website if you're interested in checking it out. It will certainly help provide additional context to today's session and in the last session of our unit as well. So in 2 weeks, we will have our last session of the hydrogen unit before wrapping up our unit with the workshop and our bootcamp series as a whole. Next slide, please. So I would just like to take a quick moment to provide an update from the run today. So the NACFE team is well underway with our site visits to the various participating fleets. We're learning a great deal about the vehicles and their operations during these visits that we're really excited to share with you all throughout August once we release those fleet profiles. So those fleet profiles will begin dropping the very first week of August. Be sure to stay tuned into the run to get a first look at the fleets and their trucks. Next slide, please. So as always, I have a few quick pieces of housekeeping to get through before we introduce our panel today. Our sponsor for today's session is Shell. Thank you so much to Shell for your ongoing support, not only of Run on Less, but also for NACFE as a whole. That way we can ensure that we are continuing providing valuable programs like this to our audience. So thank you to Shell. Next slide, please. Make sure that you go back to the landing page for this session on runonless.com to take your quiz. It will be available immediately after the session. Our speakers have sent in great questions about the topics that we're covering today. And just a reminder that once you successfully complete your quiz, you will have a link to a Google form that you can fill out, provide your contact information, and enter a drawing to win some Messy Middle swag. You'll see that Google form linked once you receive a 100% on your quiz. And as a reminder, you can submit your information to the Google form once for every quiz that you complete. So this will be a maximum of 9 submissions, and that way you'll have a greater chance to win the drawing. Next slide, please. Our final reminders here, this session is being recorded. It will be posted online later this week. If you didn't have a chance to submit a question on the registration form and you would like to do so, please use the Q&A controls in the upper right-hand corner of your screen. During the Q&A, I will be relaying your questions to our speakers. And finally, Stephen Babcock with ACT News is here to help troubleshoot any issues that you might have. His email is here on the screen, so be sure to reach out if you're having any difficulties. And if we could go to our next slide, we will go ahead and get started. I would like to introduce you to our second hydrogen session panel. Thank you so much for our panelists for being here today. Our first presentation will be from Des Carlisle, who is the Executive Director for the Southeast Hydrogen Energy Alliance, otherwise known as SHAE. Des, thank you so much. The floor is yours.
Thank you so much, Rachel, and thanks for having us today. We're excited to come and tell you a little bit more about SHAE, the Southeast Hydrogen Energy Alliance. So if we can go to the next slide, I'll get started. So SHAE actually has a long history. It actually started in 2006 as a South Carolina Fuel Cell Coalition. Over time, we often joke that we realized we weren't California or Texas and we needed our partners in our neighbor states to make it work. So around 2015, 2016, we reimagined ourselves really into a regional organization. And then in 2023, we received an angel investment that helped us completely relaunch the organization with 3 really clear pursuits. And that's what I want to talk about today is first, here in the Southeast, how do we drive innovation and collaboration? For us, that's how do we make sure that networking is happening and that manufacturers and producers are also finding the customers and the demands. We're really trying to be that bridge that links together. Second is education. It's such a broad and big word, but at SHAE, we take a different approach. We think of it really as a triangle, right? How do we make sure that state energy offices, state economic development, and clean cities within each of the 10 states we represent really have the resources they need to help drive the hydrogen ecosystem here in the Southeast? And finally, policy enablement. Again, it's not a lot of lobbying right now. It's more educating on the policy side. How do we make sure that our educators in these 10 states have everything that they need to write great policies or to avoid some policies? So that's a little bit about SHEA. I appreciate the opportunity. If we go to the next slide, you'll see the 10 states we cover. I wanted to just kind of set the tone with who SHEA was and what we do. And then I really get to set the foundation today on how hydrogen is stored and distributed. So you would think living in Nashville, I would have a jingle to this by now, but I don't. We cover 10 states: Georgia, Alabama, Mississippi, Florida, South Carolina, North Carolina, Virginia, West Virginia, Kentucky, and Tennessee. So let's get started. We'll go to the next slide. And today, like I said, we're going to dive in really fast to how hydrogen is stored, delivered, and share a few case studies. I hear you guys had an awesome webinar last week on how hydrogen is made. So now it's just taking it one more level up. So let's go to the next slide and jump into how hydrogen is stored. There's really 4 main ways that hydrogen can be stored. Geologically, it can be compressed, it can be liquefied, cryogenic, or material. So geologically, here in the United States, we actually have the largest hydrogen storage underground as anywhere in the world in Delta, Utah. It's called the ASA Delta Project, one of the largest LPO-funded projects in the history of the LPO office. Next up is compressed gas. So it can be stored just like a CNG almost. It's compressed, it's stored in tube trailers or tanks. You have to remember though, hydrogen's 14 times lighter than air, so it's very, very hard to store it compressed, but it's a great way to store it on site. Liquefied or cryogenic, Plug Power kind of leads us here in the Southeast from a liquefied standpoint. It is very, very, very cold to liquefy hydrogen, but it's a great way to transport a lot of hydrogen. And then finally, material storage. I often joke we need the PhDs to explain that piece to us, but I think it's important to understand that there are material storage out there and a lot of different ammonia, fertilizers, and so forth that we use. So that's how hydrogen's stored. So let's go to the next slide. And we're going to talk about how it's delivered. So right now, delivery is by far the most expensive part in the hydrogen ecosystem. We have some pipelines. There's about 1,600 miles of pipelines dedicated to hydrogen, most of those outside of the Houston area. Will we be able to use natural gas pipelines? There's a lot of work going into that to see what is the embrittlement issues and whatnot. But it'll be interesting to see if pipelines is part of how it will be delivered in the future. Over-the-road cryogenic liquid tanker trucks. As I said, here in Nashville, we see these often from Plug Power. So big white trucks, green letters, going up and down our interstates here, taking it from their Georgia and their Tennessee plant. And then finally, over-the-road tube trailers. So another great way to transport in high-pressure cylinders. Again, will there be a lot of delivery of hydrogen, or will most hydrogen be made on site? That's still up in the air. Let's go to the next slide. Let's talk about some real-world applications here. So real-world applications. Let's start with Class 8 trucks. Most people, if you ask them in those 10 states that I just talked about, do we have any actual trucks on the ground? Most people would say no. But the fact is we have 21 Class 8 Hyundai trucks running today in Savannah with hopes to get that over 100 by the end of the year. Class 8 trucks have continued to be a great market for hydrogen. Again, we talk a lot about what is the right energy use case, and medium and heavy duty is really where that is at. Hydrogen here in the Southeast kind of got started with forklifts, about 60,000 forklifts. We often say if you have more than 50 forklifts in your fleet, hydrogen makes economic sense to switch to. There's no downtime. You can pipe it inside. It's the only gas that can be piped inside without ventilation. And also, its only byproducts are water and heat. So in the winter, it keeps your drivers really warm. Fuel cell transit buses. Quite a few fuel cell transit buses throughout America right now, but we really see these emerging in other countries. but could be a great resource and a great starting point as we think about different cities and how do we partner to make sure that cities are getting started down this hydrogen journey. And finally, light duty. So there's about 17,000 light duty vehicles today in America. Most of all of those are in California, where the stations are. But will they continue to evolve like battery electric has? We'll see. But we do think it's a complete disruptor as we think about that medium and heavy duty. Let's go to the next slide. So now that we've talked about how it's stored, how it's delivered, and what are real world applications, I want to give you some tools to learn and grow. The rest of the guys on the panel are going to dive deep today, and I'm so excited to hear everything they have to talk about in these topics. But where do you go to get the baseline education? And that's really what we created at Shea. We wanted to create a website and a place where you could go and learn so much more at your own pace. So our website, seh2.energy, has a ton of learning techniques. So the two I really want to point out are Hydrogen 101. I call it my parents' page. It's a quick, easy page to learn how hydrogen is made, how it's delivered, stored, and in use cases. You can click on the icons. It's a stair-step education approach, so you can really dive deep. And there's also a lot of printable PDFs that are really helpful as you're sharing the story. And then finally, the Learn button. So we put together hundreds and hundreds of catalog of resources, from articles to webinars. Our goal is to provide three things: make it credible, make it trustworthy, and make it somewhere you want to go and learn those basic things. So every week that's updated on our resource page, and it has great search features. So you can go look, say you're looking for delivery, you can type in delivery and it'll tell you exactly where to find what. So mark this down. It's also in the resources that Rachel will send out as well. And so again, we just are so appreciative for the opportunity to be here to tell you a little bit about our organization and also set the tone for today. So thanks again, Rachel. I'll turn it back over to you.
Des, thank you so much. And as Des mentioned, I definitely want to encourage folks to go and explore the Shea website. It is a great website. It is very easy to navigate. A lot of educational resources there. The landing page of this session on runonless.com is going to include that link. So thanks so much again. Next up, we have Paul Sandstead, who is the Director of Technology and Sustainability with the Transport Project. Paul, thanks so much for taking the time to be here with us today. I will pass it over to you.
Great. Thank you, Rachel. And thank you very much for the opportunity to be with you all today and to give you some even more information than Des provided to us on hydrogen fuel distribution and storage. Stefan, if you want to go to the next slide, please. As far as discussion topics go today, for the next 9 minutes, I'll be covering the 4 listed on the left, but I also wanted to provide a quick introduction to the Transport Project in case you're not familiar with us. Maybe you've never heard of us. You might know us by our former name, NGV America. We rebranded last year to be more inclusive of not just natural gas, but also hydrogen now. So in general, we tend to do a lot of analysis, evaluation, and supporting of the fleets, considering hydrogen, also considering the technical distinctions and nuances that might exist between gaseous compressed hydrogen and liquefied hydrogen. So that's a little bit of what I'll be covering today. Next slide, please. So just the next few slides I'll be covering the challenges and opportunities for gaseous and liquefied hydrogen to fuel commercial trucks. Next slide, please. And so there are a few fueling challenges that currently exist in the transportation industry and sector when it comes to fueling with hydrogen. Quick shout out to High Performance Energy Systems for letting me borrow this slide. But in terms of power consumption, compressed hydrogen is actually not the most efficient fuel when considering the needed compression and chilling equipment and processes for the refueling. Reliability of compressors has been a concern in recent years. Maintenance costs is also tend to be a challenge in recent years. And I think in general, hydrogen refueling technology is relatively nascent in the transportation sector. Some of the kinks are being still worked out, so related to fill times, successive fills, and the complexity and cost of the refueling equipment. These are all challenges that need to be addressed and will be addressed as the technology continues to advance. Next slide, please. As far as analysis of the production and delivery of hydrogen, you should be thinking about how the hydrogen is produced. What's the feedstock for the hydrogen? Is it water? Is it methane? And ideally, it should be green methane. The carbon intensity of that methane should be at least lower than whatever fuel a fleet is using today. In terms of delivery, you need to think about the storage containers that would exist on the vehicle. I need to think about whether you're going to use compressed hydrogen or liquefied hydrogen, how it's going to be distributed, and then finally how it's going to be dispensed into the vehicle. And when you're thinking about those delivery performance results, you've got to think about cost and you got to think about carbon intensity. If you're not seeing those two factors come down compared to whatever fuel you're currently using, you might want to either reconsider the approach and the strategy you're taking to transitioning to this fuel, or maybe even consider a different fuel. But cost and greenhouse gases, you definitely need to look at reducing those when considering alternative fuels. Next slide, please. In terms of carbon intensity, I've got a quick slide here as an example with liquefied hydrogen. This graph comes from California Air Resources Board, and they're looking at 3 production pathways to produce hydrogen, the liquefied hydrogen. So on the top section of the graph, that would be steam methane reforming. Next section down is methane cracking. And then lastly, electrolysis is that bottom section. And you can see all these orange and blue dots, which represent gaseous or compressed hydrogen and the liquefied hydrogen. And so you can tell, like in general, the orange dots tend to be a little bit further down on the carbon intensity scale compared to the liquefied hydrogen, which tells you, in general, compressed hydrogen tends to be a little bit more environmentally friendly and allows for decarbonization a little bit better than liquefied hydrogen. So you can also see that in terms of carbon intensity, that dotted line right in the middle, that shows where carbon neutrality is for producing that hydrogen. And really only whenever you're using dairy manure or basically biomethane that's produced from decomposing organic matter and using that as a feedstock to produce the hydrogen, only then can you get carbon negative with the fuel. But in general, a lot of those dots on this graph tend to be on the higher end of that scale, that carbon intensity scale. Next slide, please. Real quick look at a typical compressed hydrogen distribution system. After the hydrogen is produced, it'll go into a compressor. From there, it'll be distributed through a transmission pipeline, going to a gaseous terminal. You can see the equipment that is typically required at a gaseous terminal. From there, it'll go to a tube trailer or a mobile container, which would then take it to a fueling station. And that could be any end use application. But we're talking about transportation today, so we're going to imagine this hydrogen going to a hydrogen refueling station, and you can see the various equipment that's typically used at that station. Next slide, please. Next up is a typical liquefied hydrogen distribution system. Instead of that hydrogen being compressed into the distribution pipeline, it is going to be liquefied. That liquid hydrogen would then be taken to a liquid terminal, and then from there it would be transported on another truck, and that would then go to a refueling station. And you can see typically what the types of equipment that is required at that refueling station. Next slide, please. Next 2 slides are going to compare gaseous hydrogen storage containers, or the compressed hydrogen storage containers, to the liquefied. And I've got 6 different factors to consider in terms of comparing the two. And so first off, In terms of compressed hydrogen, the disadvantages compared to liquefied is that it is not going to be as energy dense. The cost of the fuel is going to be a little bit higher, and the cost effectiveness of the equipment and the storage containers on board the vehicle is not going to be as good. It's going to cost a little bit more. But in terms of the fuel being available, the long-term storage of the hydrogen in the containers and the carbon intensity, those are actually more advantageous compared to liquefied hydrogen. Next slide, please. On the liquefied hydrogen side, we flip the script. The same disadvantages that existed with the compressed hydrogen are actually more advantageous with the liquefied hydrogen. So completely different ways of thinking about the advantages and disadvantages of the two fuels. Next slide, please. Real quickly on a cost comparison, we tend to see better efficiency with the liquid hydrogen when considering the storage, transportation, and dispensing of it compared to the gaseous or compressed hydrogen. In general, the liquefied hydrogen is better suited for large-scale production and distribution, which can make it more economical than gaseous hydrogen. And you can really see it from all the different costs associated with all the production pathways of the fuel. They tend to stack up a little bit higher on the gaseous side. Next slide, please. On compressed hydrogen transport trailers, there are lots of different manufacturers out there. The two that are probably the most prevalent are Quantum Fuel Systems and Hexagon Agility. They make different size trailers. This slide shows two of their 53-foot trailers containing the mobile containers, either for compressed hydrogen. I'm sorry, these are just compressed hydrogen containers inside these trailers. Next slide, please. On the liquid side, you can go on to the next slide after that introductory slide. Thanks to Chart for providing this slide. In general, considering liquid over compressed, the liquid is 4 times the energy density. So that just makes it that much more efficient in getting it from point A to point B. Next slide, please. I think this is my last slide. In terms of fill considerations, of course, you got to consider purging, cooling, temperature and pressure control, flow rates, filling times, safety protocols, monitoring, environmental considerations, and especially trying to prevent those hydrogen leaks, which hydrogen is considered as an indirect greenhouse gas. So the more you can mitigate those leaks, the better. And then comparison graph table on the right side. Time to fill is pretty equivalent. Capacity with liquid hydrogen is much better. Of course, pressure inside the storage containers is much higher with compressed hydrogen, and the offload time isn't that much different, but a little bit better with compressed hydrogen. And with that, I will turn it back to you, Rachel.
Perfect. Thank you so much, Paul. And as we're moving forward to our next presentation here, you guys are going to see an appendix from Paul's slides. We're not going to go through that material right now, but the slides are going to be sent out and they will be available online. So make sure that you go and explore the appendices in Paul's presentation. So thanks so much again, Paul. Our next presenter today is the Vice President of Business Development for Air Liquide, Charles Sanders. Charles, thanks so much for joining us today. I will pass the mic over to you.
Okay, thank you, Rachel. So what I'm going to do is enjoy being third and getting to build on what Des and Paul showed you. So if you could go to the next one, please. Stefan, Air Liquide is a company which was founded in France in 1902 when two Frenchmen figured out a way to do cryogenic distillation of air into liquid oxygen, gaseous nitrogen, and then having some argon there to do welding with. So it's literally liquid air from the start. I'm not going to read all my slides because I figure you guys would be bored out of your mind if I did that. So we've been doing hydrogen for a long time. I'm 30 years with Air Liquide, and when I got hired, I was actually selling hydrogen purification equipment. So we've been doing this for quite a while. We do it around the world, and I'm going to show you what we're doing today going to flip from the southeast United States over to let's say the West Coast. If you go to the next one, please. I work for the part of Air Liquide which we think of it as a skunk works, which is focused on hydrogen for let's call it energy transition applications, foremost of which is mobility for us. We think about hydrogen differently than our big industrial customers who buy off the pipeline on the Gulf Coast, who tend to be refineries, petrochemical operations, and whatnot. But we really are focused on mobility, and so that's what I'm going to show you today. If you could go to the next one, please. Thank you. So here we've got a pretty simple schematic. If you're thinking about mobility, let's start at the bottom. You can move hydrogen overseas to places where energy may be more expensive. That can make sense. It's not really what we're talking about today. Going up to number 2, it is possible to use liquid hydrogen on board in such things as ships, planes, and even trucks. There are not a whole lot of trucks today that use hydrogen, liquid hydrogen on board. So we're really going to focus on number 1, which is liquid hydrogen for road logistics. So what we do is, as you saw in some of the previous presentations, we produce it, we liquefy it, we're going to transport it as a liquid, and then we're going to get it onto the vehicle in the form of gas so that it can be used by the fuel cell to produce electricity on board. If you could go to the next one, please. Paul talked about gas versus liquid. This schematic here, I think, is interesting. If you look at the liquid hydrogen trailer, which can carry 3.6 tons, so 3,600 kilograms of hydrogen in that thing, depending on the pressure of the gas in the gaseous trailers, it takes a lot more trailers to move the same amount of energy around. And so this is one of I'd say the biggest benefits of liquid hydrogen. It costs more to liquefy. When Paul was talking about the carbon footprint, the liquefaction consumes energy. And so unless you're using zero carbon electricity, you're going to increase the carbon footprint by a bit. But it takes so much less space. And so if you think about moving large volumes of hydrogen, it takes a lot of gaseous tube trailers. And if you think about storing it, it's going to take a lot more steel on your site in order to store the same amount of energy. If you go to the next one, please. That's a picture of one of our liquid hydrogen delivery trailers that we're using today. In the top left here, you have a shot of our North Las Vegas liquefier. This thing was started up in 2022. It's been operating safely, reliably, and very successfully for the past 3 years. On the bottom, you have what I think of as our hydrogen Epcot. This is the 130 metric ton spherical tank. That's a very large storage vessel that we have there in order to help us be more reliable. On the right side, you have some pictures of vertical liquid hydrogen storage tanks that was, I took this off the Air Liquide website. This is how we store hydrogen in the field, okay? I did get a question from somebody, why can't we bury the hydrogen tanks like we can diesel? Talk to your fire marshal how he feels about burying many tons of liquid hydrogen. It's feasible, it's physically possible, but the economics and the OpEx of doing it that way tend to not make economic sense. So anyway, storing hydrogen is something we do today. If you go to the next one, please. This is where we're moving hydrogen around as we speak right now. Our liquefier is located in North Las Vegas. It makes 30,000 kilograms a day, so that's 30 metric tons. We have trailers that are moving all over the West Coast. We tend to focus in Northern California and Southern California. There's one station in between. And so that is what we are doing today. Okay, so when people talk about hydrogen being some sort of a sci-fi thing in the future, if you want to look at one of the places which is the most active in the world for mobility, it's California. There are a lot of cars on the road. Will there be a lot more? We're not really sure. We are seeing more and more and more hydrogen fuel cell buses on the road every year. We're doing a significant amount of business with more and more transit agencies in California, and of course, hydrogen fuel cell trucks, which is of course the point for run on less. If you could go to the next one, please, and I think this is probably my last slide. What we have here is a reminder that when you have a cryogenic liquid, and we're talking, I don't know, something around minus 450 F, right? This is very, very cold. When you move liquid hydrogen around, if you put energy into it, you tend to vaporize it into gas. And if the customer's process is pumping liquid into to turn it into gas and put it in the vehicle, anything that you do that turns that liquid into gas is basically lost for the process. So today, for industrial applications, what is normally done is you use a little bit of ambient heat, you pressure up the liquid hydrogen delivery vessel, and you push the liquid into the customer's tank. When you do that, you introduce heat, which means some of the liquid turns to gas, and you have some losses. What we've developed at Air Liquide, and we've actually patented this, is something we call the Advanced Delivery System, ADS, where we are cryogenically pumping the liquid from our trailer into the customer's tank, which means that you don't have the losses, you don't have that vaporization of liquid to gas, and the liquid that is in the customer's tank doesn't see the energy increase, which means the temperature stays lower, and you're not losing as much usable product there as well. So this is something which people don't talk about too much if they're not in the industry. The cost of the liquid hydrogen delivered is one thing, but the cost of the kilogram that gets put into the vehicle does suffer the more losses you have of liquid that's turning into gas as part of the process. And so we feel like this is an important step to helping make the cost of the hydrogen delivered and dispensed into the vehicle lower per kilogram. So I think that's probably my last one. If you go to the next one, appreciate your attention, and on behalf of all the people, I will just say, I think all of us, all the panelists here, we're working for organizations that are all about trying to help develop this technology, which is a wonderfully carbon-free way to move energy around. And so anything that helps hydrogen sort of reduce carbon footprint, I think, is a good thing. So thank you very much for your time.
Sorry, I think I lost you on the last portion of your presentation here, Charles, but I think I'm back. Are you able to hear me?
Gotcha.
Perfect. Okay. Sorry about that, everybody. Well, thank you so much, Charles, for your presentation. We'll certainly call you back for the Q&A portion here. But last but not least, we have Eugene Reyes, the Hydrogen Commercial Mobility Lead, Low Carbon Solutions for Shell. Eugene, thanks so much for taking the time to be with us here today. The floor is yours.
Thank you, Rachel. I really appreciate it. So going on and starting off with the next slide, please. Yeah, at Shell, we are very excited to be part of, as what Charles just said and the rest of the panelists, a very exciting time moving for hydrogen, particularly in California, just to start off. We believe California has very favorable winds to make hydrogen very competitive. But just to start off on this initial slide, let me tell you a little bit about what we're doing. So we have a lot of active projects throughout the globe today. And for this particular session for Run on Less, I'm going to hone in on North America, particularly California, and hydrogen mobility. We at Shell see hydrogen playing two key roles, starting with decarbonizing hard to abate use cases, along with enabling renewable-based energy systems. But I want to touch on the three key challenges that, again, we collectively as ecosystem players need to combat together. And starting with developing the right applications. Again, clear focus for us is developing heavy-duty mobility in California today and throughout North America. Second is developing the hydrogen infrastructure fast enough. Specific to mobility infrastructure, it requires a lot of real estate. And when you think of how you're refueling trucks today, trying to retrofit that with minimal real estate and entry-level technology could be a bit challenging. And lastly, making hydrogen competitive is going to require a lot of scale up and a lot of support from all the ecosystem players, again, starting with the agencies and industry players alike. Next slide, please. So in this next slide, I want to touch on how Shell has played a big role in operating and maintaining, owning hydrogen refueling stations. So believe it or not, we've been operating stations since 2008 out of California. Our first station was a light duty station, and it was the first of several archetypes that we tried from 2008 to present day. So Santa Monica was really unique as we put all of our equipment on top of the canopy. And again, just picture a Shell gas station and all of that equipment on top of the canopy. And then from a supply perspective, it was actually green hydrogen. We were using alkaline hydrogen through electrolysis. And so it was a very small volume for entry-level light-duty vehicles coming in. 2 years later, we tried our hand in developing a new station at Torrance in 2010, where we used advantageous pipeline. So pipeline made it very easy for us to start to look at how to put above ground equipment in this archetype to where we were providing the market demand for the light duty vehicles coming through. And then in 2012, we opened the station in Newport Beach, California, where we did on-site SMR. And so that was great hydrogen, and we were producing around 100 kilograms a day. And then there was a point there from 2012 to 2018 where with our partners, we started to look at what the market was needing, what type of station archetype and supply delivery system would work best with what was readily available. So we decided on our last and final batch for light duty stations to go with a delivered model for gaseous hydrogen. So when a low, medium, or high pressure trailer were to offload supply, it would go into our above ground storage vessels. And at our archetype Shell stations today, we have them horizontally stacked 5 by 5. From there, through a diaphragm compressor, they're compressed to 920 bar, to where through then a chiller, they are chilled to minus 40 degrees Celsius to create a cascade flow to where that hydrogen is dispensed at 350 bar or 700 bar, refueling trucks and buses alike. So with that, when you think of light duty setting the scene for us and our heavy duty focus, we made the difficult decision to pivot from light duty, which gave us a lot of learnings from 2008 to 2023 to where now we focus purely on heavy duty mobility stations in California today. Next slide, please. So through the ZANSEV project, we started building heavy duty stations starting in Ontario in 2020, fast followed by 2 hydrogen stations in Long Beach, Port of Long Beach, and then also at our Wilmington plant in Long Beach. And so today, our archetype for heavy duty stations matches a lot of what we learned through light duty. With heavy duty stations, it required much more land, and the modeled capacity per each of our 3 stations is 1 ton per day. What we've seen, again, since 2008 is that hydrogen is here, and our customers are coming through our station, depending on state of charge. They're refueling anywhere between 10 to 30 minutes. It's a great experience. We've gotten nothing but wonderful feedback. And these 3 stations, though initially intended to demonstrate the art of the possible of hydrogen being moved from the ports, in this specific scenario, Port of Los Angeles and Port of Long Beach, and going into the Inland Empire. So again, we at Shell see this is just the beginning where hydrogen will continue to move at a clip, and that will require all the ecosystem players to continue to push forward. Yes, there are a lot of headwinds, but we strongly believe, starting in California, that together, if we can continue to push, hydrogen is here today and will be here tomorrow. So with that, I know it was brief. I want to pass it back to Rachel and the panelists, and ready to take any questions.
Perfect. Well, thank you so much, Eugene. And if we could go to our next slide here, and if I could have all of our panelists come back, we'll go ahead and get started with our Q&A. So my first question for you guys today is going to be about the differences between liquid and compressed, because we talked about that a little bit through, it was kind of a common thread through everybody's presentations. I'm wondering if we could put a little bit more of a further definition on kind of the differences between the two. That way folks can start picturing what's going to work best for their operations. And that's kind of open question, whoever comes off mute first.
Tell you what, I'll start with that because in full disclosure, I just sent that question to Rachel. I think we sell both, and I thought it would be helpful to make it clear which one is better, a screwdriver or a hammer. Okay, well, you know what? It depends on what you're doing. And so gaseous, hydrogen, and liquid, they both have a role to play. It's not that one is better than the other. Spoiler alert, if you want some free swag, remember the number 200, because according to our analysis, roughly speaking, given certain assumptions about cost, if you can move the hydrogen less than 200 miles, it's probably going to be cheaper than moving liquid. But as you saw from my slides, it takes a lot of trailers to move around gas. And so if you're close, you might be fine. If you're building an on-site, which is going to make the hydrogen and put it directly into the vehicles, that can be really great. Then you don't need to move it at all. But if your thing goes down, you're going to need some backup, and your backup, the most energy dense, is going to be liquid. So anyway, I'll kick it to some of the others, but it's not like one is better than the other. They're good at different things.
Mm-hmm. Mm-hmm. Anything else to add?
I'll follow Charles there, Rachel. So yeah, as I shared in one of my slides, back in 2018 with our key partners, we decided on a gaseous strategy. Mm-hmm. And it wasn't because we preferred one or the other. It was one was more readily available and accessible to meet the market demands. And it's currently what we're adopting today, but it doesn't mean we won't look at different alternatives like liquid moving forward.
Mm-hmm.
I think Charles said it's complement that each fuel complements different needs or uses in the transportation sector, and I think it's interesting. It'll be interesting to see in the next decade or so which, whether it's compressed or liquefied hydrogen, becomes more prevalent. And from what we're seeing from an industry trade association perspective is the large scale production of hydrogen, it tends to favor liquefied more. And I think that's going to play a big role in the liquefied hydrogen becoming more prevalent, maybe more cost effective. And so it'll be interesting to see in the next decade or so which of those fuels become more prevalent. But at the same time, both liquefied and gaseous hydrogen both have roles to play in the transportation sector.
Paul, sorry, I didn't want to interrupt you. Are you able to mute your mic and then try to turn it back on? You got a little bit staticky there for us at the end. Hoping that helps. I'm hoping that. Okay, that sounds good. Thank you. No, but I think this is great, and I think that it's very helpful to have so many representatives on this call specifically who can speak to the various methods of this distribution. I think this is great. We got a question from one of our audience members here now about kind of the order of magnitude costs for gaseous storage versus liquid for liquid hydrogen. I'm wondering if you guys are able to speak to that at all.
Okay, I'll take that one by saying I would have no idea what sort of numbers to give you just off the cuff, and it would be pretty difficult, I think, to even throw out a pithy number because the pressure that you store the gas at is going to have a huge effect on how much steel it takes. And so I don't know, guys, anybody else care to take a shot at that one? I wouldn't even know how to do it off the cuff.
I can take it. I think I covered that a little bit in my slides. And what we're seeing today is, again, when it comes to large scale production, I think that's going to really play a big role in the future cost and the current cost of the fuel. Today, we're seeing, because of large scale production, liquefied is a little bit better in terms of cost. But if for those fleets that are maybe using less hydrogen vehicles, they're not going to be consuming as much. So a smaller scale um, use of it might tend to favor compressed hydrogen. So it all depends on the end use application, the size of the
Yeah.
fleet.
Rachel, was the question about the cost of the hydrogen or the cost of the storage itself?
Let me go back and look at my questions here. For storage, looks like it was
Yeah,
storage.
that's a that's a more nuanced answer.
Yep,
Mm-hmm.
yep, yep.
Gotcha.
Good thing you brought that up, Charles. So in terms of storage, the liquefied hydrogen tends to be a little bit, I'm making sure I'm getting it right, going back to my slides. Um, it is more cost effective with liquefied.
Mm.
Gotcha. Gotcha. So one point, and actually, Paul, this is something that you had mentioned in your presentation. We got a question about this toward the end about hydrogen gas being perceived as a greenhouse gas, and one of our audience members wants to know if you guys can speak to the current industry strategies for addressing fugitive emissions of this hydrogen gas. Are you guys able to share kind of best practices that have been developed by the industry, or what are you guys seeing as those industry strategies to kind of help mitigate that?
Yeah, so it is really important to mitigate or to control, to minimize the leakage of hydrogen. It is an indirect greenhouse gas, which means if it were to escape into the atmosphere, it might not have a direct impact on greenhouse gas warming or climate change, but there are chemical reactions that happen in the atmosphere that would then create greenhouse gases from the hydrogen escaping and having those reactions with the other molecules in the atmosphere. So in general, I think it's really important to have really good flammable gas detectors, have leakage detectors, any sort of monitoring that can be added around a refueling station or around a hydrogen production facility. I think that's
Mm-hmm.
really critical to control those hydrogen leaks, and it's also lends itself to a much safer operation. Obviously, hydrogen is very flammable, so the more you can control the leakage of those gases and potentially leading to a fire or explosion, that's obviously important as well.
Mm-hmm.
I would throw out, as I mentioned before, we want to keep it liquid as long as we can because that's going to help keep it where it needs to stay.
Mm-hmm.
I have had the opportunity to go to a hydrogen refueling station that Air Liquide owns in France, where they have sonic cameras of all things, which you can't see hydrogen leaking because even when it's burning, it's invisible unless it's nighttime. And they have sonic cameras on some of the stations over there to detect the noise from the leak and help detect that even when you can't see it. So as far as we're concerned, any hydrogen that gets out is just money that somebody's losing, and so that's another reason for us to try and keep the leakage down.
Mm-hmm. That actually gets into one of my next questions here, specifically about the safety standards. So obviously, looking at what folks have been talking about regarding, or I guess how folks get a little bit nervous about heavy duty battery electric vehicles, potential vehicle fires. There's some concern there, and I feel like there's always concern when there is a relatively new technology about the safety of the distribution and the storage. What, aside from the leak reduction, what are some of the strategies that the industry is adopting in terms of safety standards for moving the hydrogen itself? Are you seeing folks get nervous about that? And if so, what are those strategies to kind of mitigate those concerns?
Nobody else wants to jump in, I'll take a stab at it. Stefan, if you could go back a few slides to my appendix, there's a slide on a CSA group research report. It shows a liquid hydrogen tanker. That's the one. So I'm going to provide a real quick promotion to the CSA group report. It does a great job of outlining codes and standards, regulations that promote safe transfer and transportation of both liquefied and compressed hydrogen. So I would encourage attendees to go here first and foremost. But there are lots of opportunities at the same time for these code standards and regulations to grow and to further specify increased safety concerns with the hydrogen. So it's in general the code standards do exist, but there's lots of opportunities to grow and to increase the content in those documents.
I can give a shout out to there's an industry group which is called the Center for Hydrogen Safety, which I think we're one of the founding members. I would imagine Shell's on there as well, right? So
My next slide has, if Stefan can just go to the next slide, I got a quick shout out for them as well.
yeah, okay, that's great. So I think most people, as I mentioned before, hydrogen has been around for a long, long time, and people tend to think about, Zeppelins burning back in 1930, right? But you don't hear about hydrogen burning very often because industry uses a tremendous amount of hydrogen, and it's done very safely. I think as hydrogen starts to be used for more and more things, people start to learn about it and get nervous about, hey, doesn't this stuff burn? Well, you know what? Any transportation fuel, including batteries for that matter, is going to burn if you don't treat it right, right? So the codes and standards are there when you respect them and when you know what you're doing. I think it's as safe as anything else.
Yeah, Charles, I would just state that from a hydro refueling infrastructure perspective, dispensing hydrogen, we think hydrogen is very safe. And so we've dispensed a lot of hydrogen since 2008. And just to give a flavor of what we do in onboarding fleets and customers, there is an official session that we do. And it's very clear to all parties involved on why it's safe. We always get that question. And so Shell definitely wouldn't be continuing to push the envelope with our current stations in Southern California and potentially looking at future station expansion if we didn't think it was a safe new fuel for new vehicles. So if that means anything, I hope that sticks.
Yeah, I think that sounds great. And I think that this actually speaks back to the beginning of our presentation around the education piece, which, Des, you talked about Shea's position in this industry as a real industry educator. I want to hear from you. What topics are the biggest points that Shea is seeing that folks need education about with the hydrogen industry? Where are the biggest points of misunderstanding? Where are those opportunities to kind of come in and help get everybody on the same page about where the industry is and where it's going?
Absolutely. Thank you, Rachel. We often joke here in the Southeast, it really is what the heck is hydrogen, way more than like California or Texas, who's more advanced in that space. So we spend a lot of time just talking about the basics, right? It's hard to jump to middle school when we haven't been to kindergarten. And so not assuming that everybody knows what hydrogen is, even though it's been around a long, long time and it's the most abundant element, how do we use it as a fuel, and just trying to break that down. So we spend a lot of time talking about the basics, and then we try to build up from there. So we talk about everything from how it could be used, how it is being used. A lot of people have no idea that we're producing hydrogen in Tennessee and Georgia today with Plug Power. And so it's exciting to showcase what's going on here in the Southeast, but what are the potentials for it? But before we can get into any of that, it's really about the basics and trying to make sure everybody understands that it is safe, that it has been around, that like you guys said, it's been dispensed many, many times, and we're not the first state or the first little city to do that.
Yeah, I think that makes a lot of sense, and I think for folks like us who are in the kind of clean transportation industry, sometimes it is difficult to remember that yeah, a lot of folks who are not dealing with this stuff every single day, we're starting from stage one here, which is a very necessary stage to be at. So that was great. Thank you so much. I'm hoping I have time for two more questions here, because I have one here kind of about space consideration. And Charles, you had talked a little bit about storing underground versus storing above ground, and we saw the pictures of the vertical storage tanks that Air Liquide has. Can you speak a little bit about those space considerations beyond, what can be done underground, and a little bit more about the vertical storage strategies?
So we don't, Air Liquide doesn't own and operate retail fueling stations in the way that Shell does, right? So we do sell station dispensing technology, but we don't own and operate. So really the choice about how you store it is going to be a function of a lot of things, including what the AHJ says, right? The authority having jurisdiction is going to may very well have a preference about, or some, let's say, some strong thoughts about tanks that can't be higher than the blast wall, or no way am I going to let you bury something because I need to be able to walk by and see it, right? So I don't think there's any sort of one size fits all. It is possible to bury a cryogenic tank, but you have to put the seismic appropriate foundation way down and then bury the thing and then be able to drive trucks across from it. And so from our partners, and we work with, let's say, the largest commercial trucking retail truck stop owners and operators, they tend to want them above ground rather than buried. And further than that, it's going to be a function of space available and what your authorities think, I would say. I don't know. Eugene, any thoughts about that?
No, I think you're spot on, Charles. When it comes to the AHJs, again, the authorities having jurisdiction, they all have different inputs, especially in California. And I think that goes back to one of the major challenges that as part of my first slide, I touched on, was getting that infrastructure developed fast enough. Because the lead time to build an infrastructure to dispense hydrogen could take years based on the AHJ. So a lot of that is educating back to, again, safety to the AHJs specifically, who are providing those approvals, whether it's the blast walls that Charles was touching on, or the proximity of above ground equipment, which we have, can be near whether the storage tanks, the C-store involved, but a lot of it is the real estate available. And so even in California, that's very challenging, right, Charles, to find a lot of real estate, whether brown or greenfield, that we can build on fast enough to meet the market demand that we're seeing today.
Mm-hmm. Well, I think that this is a good place to wrap up here. Thank you so much to our speakers for joining us today. If we could go to our final slide here, Stefan. Our second hydrogen session will come to a close here. So thanks everybody for joining us today. In 2 weeks, we will be back here for our third and final hydrogen unit session, is titled The Opportunities and Challenges of Selling Hydrogen to the Industry. Remember to go back to the landing page of this session on runonless.com. The quiz is now available. Make sure that you provide your contact information so we can put you in the drawing for some Messy Metal swag, and connect with us on social media. All of our social media links, all of our handles are linked out here. So we appreciate all the time that you've spent with us today. Very, very special thank you to our speakers for taking the time to be with us here today, share their experience and their expertise. Have a wonderful day, everybody, and we'll see you in the next one. Take care.